Thank you very much indeed. Yeah, I'm happy to try and keep to 10 minutes. So one of the things that we need from complexity is an understanding of heterogeneous interacting entities. In this case, it's countries, and they're very heterogeneous. There you see a plot of OECD member countries and several partner countries, I think 10 partner countries there, plotted on the bottom axis, GDP per capita, vertical axis, GHG emissions per capita, excluding land use emissions. And you'll see there's a huge diversity there. So we've got some ingredients for an interesting story, I think. We've been talking about prices, how we need prices to help us with this transition, but they're nowhere near good enough. They could be an awful lot better than they are now. We have very low, ineffective carbon prices in trading systems and some taxes. These are implicit energy taxes and carbon taxes across this same set of countries, and you'll see that in the very inelastic area where we are not going to get much modal shift because the infrastructure and the opportunities don't exist for people to shift modes. You can see that governments are making a lot of revenue out of their transport taxes, very low taxes generally across heating and process use, which includes both households and industry. And electricity, we tend to actually tax the most emitting energy sources least. So that's all good messages there for policy. Another one, what are we doing with fossil fuel subsidies, fossil fuel support? Going in completely the wrong direction, and even with the recent fall in oil prices and some very positive reforms in Mexico, Indonesia, India, and one or two of the OECD sort of traditional OECD countries, because Mexico is also an OECD country, they're still too high, 160 billion to 200 billion a year, we think, in terms of support measures. If you use a sort of IEA methodology, you come out at a very much bigger figure of about $500 billion. We take your point, I think, Jim. Prices are not enough. If you're trying to deal with climate, you're trying to deal with policy regimes across all of these sectors of the economy. So the Aligning Policies for the Low Carbon Economy report this summer was released by the OECD and the IEA and the NEA and the ITF, the Transport Forum, working together. And we have climate cutting across all of this. And we know that prices, even the fossil fuel subsidies reform, will not be enough. There are lots of things we can do in other areas, investment tax, trade, competition policy, that can really help reduce the cost and make a transition to a low-carbon economy easier. Let's have a look at some of these transitions. Sorry, that's a bit small. It's an IPCC chart. The triangle in the middle is meant to show three model trajectories to something approaching a 2-degree scenario by the end of the century, and the three green boxes on the left-hand side are three different models, GCAM, Message, and I can't even read the last one myself. And they have three colours there, one for unabated fossil, that's the black, biomass, and fossil with carbon capture and sequestration, potentially negative emissions, that's effectively drawing down CO2 from the atmosphere, and then the lighter green, renewables and nuclear, which are much lower carbon. And that low carbon option is at the top of the pyramid, or the triangle in the middle. At the bottom left we have the fossil fuels unabated, and on the bottom right we have the clean fossil fuels. What you'll notice is that different models are giving different trajectories, and that different countries, presumably starting in different places, would end up with different trajectories. And what I don't think we have yet is a modelling approach that really gives us a granular understanding of where countries should go on these transitions. We just don't understand the dynamics, the transaction costs, the particular barriers and advantages that economies face in making these choices. So how would Indonesia make this low carbon transition? How would Canada make it? They might be very different, and they might have very different implications and lessons. And I, personally speaking, don't think we understand enough about how that happens or could happen. The other thing, of course, is that adaptation and mitigation, adaptation being the sort of building of resilience, mitigation being the reduction of emissions. can work together or can work against each other in various ways. We can introduce new vulnerabilities. We can actually adapt in a way that increases emissions, and the traditional one is air conditioning, but much more important might be massive desalination, for example, using fossil energy. And then there are areas where you get win-win, where you have some reuse of heat from buildings, that sort of stuff. So it's a complicated problem just in terms of adaptation and mitigation. You can't ignore adaptation for the mitigation story either. How complex do our models need to be? We're culpable, apparently. I don't think we're culpable. I think most economic models of climate change are deeply flawed. I think they're deeply flawed because we don't understand the damages properly. We don't understand how the interactions between the physical climate and the economic and social systems are going to play out. We don't understand then the linkages even within our own economy in terms of the global value chains and so on sufficiently well. So that's why the Thai floods caught everybody out. Another thing we don't really understand well is the substitutability of manufactured for environmental goods. A traditional environmental economist, Thomas Stirner, did a really neat paper, I thought, back in 2008, where he showed that you could use Nordhaus's DICE model with exactly the same discount factors and reach radically different conclusions if you just had two goods in the economy instead of one. That's a bit of heterogeneity, isn't it? So instead of just manufactured goods, let's have some environmental goods in there, like clean water to drink or something like that. And if they're not perfectly substitutable, you actually get quite different policy prescriptions. We don't understand those sorts of things well enough to give you good models of economics and policy. Uncertainty is a huge issue, both in the physical climate system, and then how do you translate that into meaningful decisions over future outcomes. And as we've heard, there's huge uncertainties about technological availability, how the prices will evolve over time, what innovation is going to do to that. So I don't think we need one complex model. I think what we need is probably a hierarchy of models like the climate scientists tend to use. You have these big global climate models that produce the outputs that we all see in the IPCC reports, but we also have much simpler models that try and get to processes to try to understand particular phenomena. And I think there's a great deal of work that could be done, for example, in trying to understand how institutions and agents might resist or facilitate changes in energy systems over time. Bon, I'm going to skip over all of that then. It's very interesting but tough. Current state of the climate models isn't that great either, in that they can tell us about things like the mean temperature, the thermodynamic properties of the system, but the dynamics is less good. Just look at the precipitation projections, for example, in any of the climate models, and you'll see that. That's a very active area of research. So that's my summary slide. We have interrelated climate policy challenges. One, how do we make that transition? And two, how do we build the resilience of the economic and social systems to that? And I think Jim gave us a very good discussion and description of some of the things that are needed in there. I'd bring out perhaps some of the more important linkages between some of these subsystems, like energy and agriculture, when you're talking about big bioenergy programs, the need for negative emissions. Very much agree prices are necessary but insufficient. And then how do we overcome and understand those barriers to the transition? I think more work needs doing there, and more experimentation as well. I'd absolutely agree. We need to create innovation ecosystems with new partners, pushing forward new ideas in new places. I'll leave it there. Thank you.